You are watching the second part of the second lesson of the course Programming in C++. In this part of the lesson, we will talk about the fundamental data types in C++. To order to keep an information, computer must have enough amount of memory. Computer's memory is limited. We represent computer's memory as a rectangle. Let's divide this rectangle into cells. Each cell corresponds to the amount of memory that is equal to 1 byte of information. Each cell has its own address. Computer uses these addresses to refer to the information that is stored in the appropriate cell. Given three numbers, it is necessary to save them in the computer's memory. We can estimate the required amount of memory to store these numbers. Create three variables that will be associated with or contain given numbers. A variable is a fixed amount of memory that contains some information. In our case, this is red rectangle. Letter near with the variable is a variable identifier. It specifies the name of the variable. Access to variables is realized by means of addresses or identifiers of the variables. So, if you want to create a variable, you must select appropriate amount of memory. In C++, you may select this amount of memory from several defined memory capacity. The memory capacity allocated for the variable determines the type of variable. When you create a variable, pay attention to numbers you are going to store in. If they are always positive, use option unsigned. It should not be overused with types float or double, especially for small integers. It is necessary to declare a variable before we start to use it. During declaration, we must set the type of the variable. In this way, we reserve required memory capacity. Also, we have to set the identifier of the variable, so we give a name to a variable. Assigning a value to a variable, you initialize the variable. During initialization, the information is written into the memory. After initialization, the information is stored in the variable. The amount of information that you store in a variable must not exceed the amount of memory reserved for your preferred type of variable. Let's say you wrote the following code. The variable a contains the number 250. The char type allows it. The variable b cannot contain the value 73,000. Not enough memory allocated to store a number. The variable c can contain the number 15, but 3 bytes of memory will be empty. Short init can store 2 bytes, but we try to write 3 bytes of information. If this occurs during the execution of the program, there are problems. Turn to the practical exercises. Let me remind you, you can upload files with examples for the second lesson from the website on gradient.com. Create a folder and call it C++ in your home folder. Put there files with sample code. Run the terminal program and type in the console next commands. Once again, the folder C++ should be in your home directory. Sample code should be in the folder C++. In the first lesson, I explained how to compile and run a program in C++. If you have trouble, watch the first lesson of the course. Open the file with the first example of the second lesson. The above code explains how to get the address of the variable using reference operator. So, symbol ampersand before the identifier of the variable lets us find the address of the variable in a computer memory. The address that locates a variable within computer's memory is hexadecimal number. Thus, the variable identifier, the name we give to a variable, allows us to access information that is contained in a variable. Access to the address of the variable is implemented by the reference operator, an ampersand that is placed before the variable identifier. Compile and run the first example of the lesson. In the console, you will get a result. Of course, the address of the variable on your computer will be different from one given on the slide. Run the program several times. Pay attention to the address of a variable when you restart the program. The value of variable's address in the computer memory after the first and second program start is different. Remember, a variable exists during the program is running. There is no need in variables if the program is finished. Therefore, all the variables of the program is automatically deleted. The memory allocated for the variables is released. When we restart the program, it creates new variables and allocates new parts of the computer's memory for these new variables. That is why variables' address in the computer memory are different. Convert hexadecimal address of a variable to a decimal number using calculator. Copy the address of a variable into the calculator. Take out symbols 0x. These symbols explain to compiler that this is hexadecimal number. In order to make a calculator understand these numbers, we use appropriate option. Now select decimal presentation of the number. The second example demonstrates the possibility of declaration of several variables of the same type in one line of code. It is also possible in a single line of code to declare a variable and assign it some value, or initialize a variable. Pay attention to the first example. It demonstrates how to assign to a variable a value that is real number, with decimal point and exponent. Also, the example shows that the variable's name is case-sensitive. The identifier of a variable can contain only letters, numbers, and the low dash. The second part of the lesson is over. In the next part of the lesson, we will learn how to access information contained in the variable using address of a variable. In other words, learn how to use pointers.